This is page 300, number 35. Okay, so number 35, we have to sketch the graph of, let's try this again, f of x equals x minus 1 over 1 minus x squared. Now this function is a little different than the ones we've been sketching because we've got some common factors here. So x minus 1 and 1 minus x are going to give us a whole when x is equal to 1. So what we can do is sketch the graph of negative 1 over 1 plus x, and then just put a whole at x equals 1. So for g of x, the domain is all reals except for negative 1. For the symmetry, it doesn't look like this function will be even or odd. It looks like we don't have any x-intercepts. But our y-intercept is happening when y is equal to negative 1. And if we look for asymptotes, we have one at x equals negative 1 and at y equal to 0. So let's find our first derivative. Maybe before I do that, I'm going to rewrite g of x as negative 1 times x plus 1 to the negative 1. So g prime would be positive 1 times x plus 1 to the negative 2. So g prime is never equal to 0, but g prime is undefined at x equals negative 1. But negative 1 is not in the domain of g, so this is not a critical number. So g has no critical numbers. And if g doesn't have a critical number, then g has no local extrema. But we'd still like to know if our function is increasing or decreasing. So our sign chart will have 1 and an x plus 1 squared. And this is a g prime, not an f prime. So negative infinity to negative 1 to infinity, 1 is always positive, and x plus 1 squared is always positive, so g is always positive. So g is increasing on negative infinity to negative 1, and then from negative 1 to infinity because the derivative is positive. So always increasing. All right, let's find our second derivative now. We'll have negative 2 times x plus 1 to the negative 3, which is negative 2 over x plus 1 cubed. Now our second derivative is never equal to 0, but our second derivative is undefined at x equals negative 1. Now again, negative 1 is not in the domain, so g does not have any points of inflection. But we still need to know about the concavity. So if we make a sign chart, we'll have a negative 2 and an x plus 1 cubed. We're going from negative infinity to negative 1 to infinity, negative, negative, and this will be a negative and then a positive, which means we go from concave up to concave down. So g is because g double prime is positive, This is because G double prime is negative. Okay, so we've got a function that's always increasing and concave up, then concave down. So we have no x-intercept, a y-intercept at -1. We've got a vertical asymptote at x equals -1. And a horizontal along the x-axis. Okay, so our graph, again, is always increasing because our derivative is positive, but we have to go from concave up to concave down at -1. So increasing concave up should look like this. Still increasing, but concave down should look like this, going through that point here. But don't forget that we're graphing f of x. This is the graph of g of x. To graph f of x, we need a hole at x equals 1. So we'll come back here. We'll say that if this is 1, then on our graph, there should be a hole right there, and then this is the graph of f of x.